And the final thoughts on this lesson are um, these two sort of error analysis problems about can we do this, and sort of a word of warning for maybe future problems in the lesson. So the first one says, does the square root of the quantity a plus b squared equal a plus b? We'll just maybe test or pick some values. So we'll say, let's say a equals 5 and b equals 6. And so the square root of 5 plus 6 squared, does that equal 5 plus 6? Well, right side would be 11, and the left side would be the square root of 11 squared, which is the square root of 121, which is in fact 11. So this does check out, and we'll put just yes. And if we think back, we can see that in fact the square root and the square cancel. On 18, though, the subtle but big difference is that there aren't parentheses here. And so we'll pick values again. We'll use the same ones, in fact. It would be 25 plus 36. And that would be the square root of 61. Well, that will kind of be part of what we're doing in this module is trying to figure out square roots of non-perfect squares. But whatever the square root of this is, which I suppose you could type it in your calculator, I know it's not 11 because if it was 11, um, it would need to be the square root of 121, and it isn't. So these are not equal. And in a similar vein as what happened in Module 5, we can't distribute a square root over a plus sign. If you think back in Module 5, we talked about how there was a problem, something like this, that a plus 2 cubed did not equal a cubed plus 2 cubed. We actually had to use like this array model to do this. And we did not apply exponents across plus signs or minus signs. We only did it over multiplication and division. And so in this case, we also can't apply a square root over a plus or a minus unless we have this grouping symbol here. So in fact, this is fully simplified.